We all know that increased stress can lead to accelerated aging, cardiovascular disease, cancer, and an impaired immune system. A new study on board the station is looking into part of the chromosomes of astronauts. To find out more about this and how spaceflight affects it, my colleague Lori Meggs at the Marshall Space Flight Center recently spoke with the principal investigator of this first of its kind study and how the one-year crew mission is taking part.
For the twin study, we are going to be looking at telomere length and telomerase activity in the astronauts. And not only the twins, we have a separate project where we're also looking at other astronauts. But we're going to be measuring their telomere length and telomerase activity in blood samples.
What is that?
So telomeres are the ends of our chromosomes, and they are very informative biomarkers of aging and disease, like cardiovascular disease, for example, is one example. That short telomeres have been associated with increased risk of a variety of diseases. Cardiovascular disease, cancer is another one. They're also important because they get shorter as we age, just all of us. As we get older and cells replicate, telomeres shorten. So it's becoming appreciated that they are very informative as far as how well or how quickly we're aging. And a whole variety of lifestyle factors contribute to telomere shortening and how fast they're shortening as we get older. So things like stress, all kinds of different stress, nutritional, physical, emotional kinds of stresses can really shorten telomeres faster than just regular lifestyles without it. So the idea was that space flight and strapping yourself to a rocket is a fairly stressful experience, and living in space, what's associated with all of that, would really accelerate perhaps Scott Kelly's telomere loss and contribute to aging and perhaps increased risk of disease as compared to his brother Mark on Earth. So that's really what started it. That's our hypothesis. And then we're also going to be measuring telomerase activity, which is the enzyme that helps to maintain telomeres, and try to tie that to the changes that we see in telomere length.
So we do this by drawing blood?
Yes. So we just go from blood samples, and we can get the DNA and the protein that we need to look at their chromosomes, to do a fluorescent assay where we look at telomere length, as well as the protein where we look at telomerase activity levels in the blood.
How can this help me here on Earth?
Well, we're all worried about getting older and aging and how quickly or how well we're aging. And we're all worried about increased risk of disease, cancer, cardiovascular disease. So if we can associate or find some specific factors that are associated with spaceflight, because with the twins, the beautiful thing is that their genetics are the same, or is as same as we're ever going to get. So we can control for that and then say it's just the spaceflight factors or these stress factors that are related to spaceflight that are influencing telomere length. So we can do other studies to show, how can we mitigate that? How could we help slow it down? For example, if it's oxidative stress, can we treat with antioxidants, a simple thing like that, to help slow down that rate of telomere length loss? And so that's going to be something that'll benefit everyone.
So you say it's not just the twins, though there are other astronauts. So how long will the study go?
The twin study, of course, the 1-year launch and then time after that. But we timed it so that we're also doing other astronaut studies over the same period of time. So we'll be able to compare the twins not only to each other for spaceflight factors, but also compare them to other unrelated astronauts to look for individual kind of susceptibility factors that might also be contributing to rates at which telomeres are lost.
So what excites you about this study other than, having a study yourself on space station?
Yes, well, just having a study on space station is really remarkable, and it's been, the challenges that you have thinking about how to draw blood on the space station and how you get your samples back and just all of those kinds of logistics that you don't normally think about. That's really been exciting and a lot of fun. And just the whole group of investigators for the twin studies are also just a remarkable group, and they've been wonderful to work with. And just, at the thought of being able to do something that no one's ever done before with the astronauts and making a contribution to astronaut health as well as to just general health of society. It's hard to top.